Okay, so we're going to explore the meaning of multiplication, and we really want to get a grasp of what this multiplication means so that we can utilize it as we move forward. Okay, the more we understand about it, the better we can actually work around it and be flexible with calculations, and the more we can adapt new information as we get it. So I want you to think about what this means when I write this. By the way, that when we write that dot in the middle, this is kind of our standard way of writing multiplication. So this is 3 times 5. Okay, so I want you to pause the video and see if you can write down, think about what does 3 times 5 mean. See if you can come up with more than one meaning for it too. Okay, so a couple of very common responses are that 3 times 5 means 3 groups of 5. Okay, so I might be adding up. So here's a group of 5, another group of 5, another group of 5. So I have 3 groups of 5. We have 5 and 5 and 5. That's 5, 10, 15. So 3 times 5 equals 15. Okay, and so when we talk about 3 groups of 5, we're really talking about adding up 3 groups of 5. Okay, so that's 5 plus 5 plus 5. Now another way to see 3 times 5 is not as 3 groups of 5, but as 5 groups of 3. Right? So this would be, here's 1, 2, 3, 4, 5 groups of 3. And so we still get, so there's 3, 6, 9, 12, 15. We still get 3 times 5, if we think about it as 5 groups of 3, is still 15. Okay, and so when we talk about 5 groups of 3, that's really adding up 3 plus 3 plus 3 plus 3 plus 3. All right, so we're going to look at a few representations of this. And one of the things that I want to look at is a number line representation. Number lines are helpful in a lot of different ways. So let's look at how would we model 3 times 5 on a number line. And we're going to have 2 different models based on 3 times 5 meaning 3 groups of 5 or 5 groups of 3. So we know the answer is going to be 15. I'm going to go ahead and put a 0 off to the left a little bit and then count out 15 spaces. And of course I'm going to count by 5s just to make the number line easier to read. So here's 5, 10, 15. So if I was to do 3 groups of 5, I can see that, so it's 5 plus 5 plus 5. And I want to really think about, like, the first group of 5 is going from 0. So there's, remember with the number line, you're counting spaces, not tick marks. So you're looking at 1, 2, 3, 4, 5. You're thinking about that 5 as a length of 5. So there's a length of 5, plus another length of 5, plus another length of 5, gets us to 15. And also we can do this with 5 groups of 3. I'm going to put the same markers here, just because I can see it's easier to count on the number line. And 5 groups of 3 looks like this. Here's one group of 3. Remember, it's 3 spaces. 1 group of 3, 2 groups of 3, 3 groups of 3, 4 groups of 3, 5 groups of 3. This is 3 plus 3 plus 3 plus 3 plus 3. This is 5 plus 5 plus 5. Okay, so a lot of us are really familiar with the fact that multiplication, you can do this in both ways, 3 groups of 5 or 5 groups of 3. And by the way, the fact that 3 groups of 5 is 5 groups of 3, or we could say 3 times 5 is the same as 5 times 3. Sometimes people get very particular about saying, when I write multiplication, it's this many groups of the second number. So I might write this one, this might be 3 groups of 5, and this one might be 5 groups of 3. But since they're both the same, it doesn't matter which way I write either one of those. But the fact that 3 times 5 is the same as 5 times 3 is the commutative property of multiplication. We say multiplication is commutative. And commutative, you might recognize the base word here is commute, which means to move. Okay, so I can change the order of the multiplication. And you might ask yourself, why can we do this? Many of us have the experience to know that we can do this, but like, why? So I want you to ponder for a minute, why is it that 5 groups of 3 is the same as 3 groups of 5? Like, looking at the number line here and looking at this picture, it doesn't seem like there's any particular reason why those should be the same thing. It seems like maybe it's just a coincidence, but I think we all have experience in seeing that anything that we multiply in this way, like 2 times 3 is the same as 3 times 2, or 7 times 4 is the same as 4 times 7. Why in the world would this be? Take a moment, pause the video, and see if you can think for a solid 2 minutes about why these are the same. So hopefully you actually thought about this and took a moment to maybe draw some things out. One thing that we can do here to make this a little bit more clear is to not draw these groups in clumps like this, but to draw them organized in rows. So if I make my groups of 5 like this, here's one group of 5, and then another group of 5, and then another group of 5. If I put them in rows like this, then something really magical happens. And what happens here is that we can actually see that if I look in rows, I have 3 groups of 5 here. 1, 2, 3 groups of 5. But if I look in columns, let me erase these groupings. If I look in columns, I can see 1, 2, 3, 4, 5. So when I look in columns, I can see 5 groups of 3. Right? So when I arrange my objects in what's called an array, which is basically just an organized set of rows, then we can actually see that 5 groups of 3 is the same as 3 groups of 5. So this is one of the reasons that we're going to be utilizing grid paper in this class, is instead of drawing those individual circles, a really nice way to do this is just to draw a rectangle. And if I have the grid already drawn, then now I can see these boxes inside here. This is a 3 by 5 grid, and I can see, I'm going to draw these lines in here, but normally I don't. And then this kind of represents the same thing. I have 3 rows of 5 boxes, or 5 rows of 3 boxes, 15 boxes altogether. So the number line has a lot of advantages to it, and we are going to use the number line for some things. But when we're talking about multiplication and later division, these grids of boxes are really, really helpful for a lot of things. Okay, I want to talk a little bit more about multiplication. Talk about some mental multiplication. So some of you may be very comfortable with your times tables, and some of you may feel uncomfortable with them. Either way is totally fine. But regardless, I want you to think a little bit about how you can calculate 7 times 4. Now, the answer is 28, and that is not the important thing here. I want you to think about, like, suppose that you don't know that 7 times 4 is 28, or suppose that even if this is something that you can recall, suppose that, you're tired one day and you have to do 7 times 4 and you're like, 28, that doesn't sound right. Is it 28? And you have to convince yourself of what it is. How can you calculate 7 times 4 in a way that means something? So think a little bit about this. How many different ways can you convince yourself that 7 times 4 is 28? I want you to pause the video and spend 3 whole minutes trying to see how many different ways you can calculate 7 times 4. Okay, hopefully you paused the video and you sat for 3 whole minutes and tried this. So, a few ways that you might do it. 7 times 4 is, 7 is kind of a little bit of an ugly number, but maybe you like 5 times 4 better. We can think of 5 times 4, and this is 5 groups of 4, is 20. So maybe you remember that better. And then you have 2 more groups of 4, is 8. So if we add those up, we get 7 groups of 4, is 28. Maybe another way we could do it is that 7 times 2 is 14. So that would be, you could think of that as 2 groups of 7. So if we double that, we would have, so we get double to get 7 times 4. 4 groups of 7 would be doubling 14 is 28. Let's see, another one we might do is, 7 times 5, maybe we like 7 times 5 better. So we can skip count 7 times 5, 5, 10, 15, 20, 25, 30, 35. You can't see this, but I'm counting on my fingers 7 groups of 5. 7 times 5 is 35. So that's 5 groups of 7. And so we need to knock off one of my groups of 7. So we subtract 7. And then we have, so this is 5 groups of 7. 5 groups of 7 minus 7 gives me 4 groups of 7. So 7 times 4, we would subtract 7 here, is 28. And even there, 35 minus 7, how do you do that? Well, I know that 7 is 2 more than 5. So if I subtract 5, I get down to 30, and then I need to subtract 2 more, so I get down to 28. So I want to look at, here's 3 different ways that I thought of to calculate 7 times 4. Maybe you thought of different ways. And I would urge you to see if you can draw a picture of these different ways. So looking at this, I'm going to see 7 times 4. Here's my 4 and 7. This is 7 times 4. 4 by 7. And I can see, 7 times 5, 4 times 5. Here's 4 times 5, so that makes 20. And if I do 4 times 2, that's 8. So 4 times 7 is 20 plus 8. So that's a picture of that. Like, that's using the grid to kind of, you can split up this grid in a friendly way. Let's think about what it looks like to do 7 times 4 in this way. So again, I'm going to go, here's my 4 by 4, 5, 6, 7, like that. And this is basically saying, well, 7 times 2, or sorry, yeah, 7 times 2. And basically doing 7 times 2 doubled. So this is 7 times 2, and there we have 14 and 14. We double 14 to get 28. Now let's do one more. Again, this is a picture of 7 times 4. And I go, well, I like, this is 7 times 4. And so I say, well, I like 7 times 5. So I like 7 times 5. So it's 35. But then we're going to go in there and subtract off one group of 7. So I had 5 groups of 7 is 35. So we subtract off 7 there. And so we're left with 28 in the box. So as you are doing multiplications and thinking about these things, I would encourage you, especially if you have some numbers that you can't always remember what their product is. 56 is kind of a famous one that people get stuck on 56. Sorry, people get stuck on 7 times 8, which is 56. And, I see a lot of people getting stuck on 7 times 4, which is one of the reasons that I brought this up. But if there's any of these that you kind of get stuck on, take a moment to pick out that one multiplication and draw some pictures and think about, here, how many different ways can I think about how to multiply those two numbers? And draw some pictures. Draw a picture that like kind of splits up the numbers in a way that makes sense, whatever sense to you. Oftentimes by going towards friendlier numbers and numbers that you like working with better, and then adapting them to get to the numbers that you're supposed to be working with here. Okay, so this is a really great way to visualize multiplication, and I cannot express to you how powerful it is to do this. And we will see some of this in a little bit in a later video.